Alrighty, so we are officially live. Let me double check a few audio. Make sure I need to make sure everything's working real quick. So, alrighty, so here we go. Hello, everyone. Looks like the mic is on, so everyone can hear me. This is Amour Learning, where we provide free math tutoring and a bunch of free online videos for people to use. So if you haven't done so already, make sure you subscribe to this YouTube channel. But yes, we do provide free math tutoring for everyone. That includes if you're in elementary school, if you're in middle school, high school, college level, or even if you're in graduate level mathematics. I can help you. And so make sure that if you have any questions, post those questions on the live chat and I will get to each of those. Now, I do have one particular topic that I'm interested in today, and that is fractions. So I'm going to be focusing on fractions in this lecture. However, you can ask any question if you want to talk about Russell's paradox or Markov chains or something involving statistics, mathematics, abstract algebra. Maybe you want to talk about polynomials. Doesn't matter. Just post your questions in the live chat. And before we get into today's lecture, I just want to mention that if you do subscribe, you get notifications, which is really useful because my students tend to, they get the pop-up and they're like, oh, yeah, by the way, I get free math tutoring. So if you have math homework, I can work that with you guys. So that being said, I do want to give you an update on this channel before I get to the questions in live chat, which doesn't look like we have any, which is totally fine because I have a topic that I want to talk about anyways today. But this channel is posting a lot of content, so keep on the lookout for the content that's being posted. We are posting right now a statistics class. The entirety of it will be finished this week, so we have a deadline September 21st. And then we are going to start actually pushing through those videos. Now, we've already pushed through a bunch of videos. We took a pause on that, and we are going to push through some more videos within the next week. So just keep an eye out. We're going to shoot for about 3 videos per day, which is a high bar for us. But just know that there are 2 people working behind the scenes here, my wife and I. So we are definitely trying to push out as many videos for you guys as possible so you guys can have some really good content to understand mathematics. Now, it looks like we have a question. Let's see here. It says, this is from, looks like Pedro, an hourglass. So here's the question, real quick. I kind of have to look a little bit to the side over here to read this. The question is, an hourglass is in a cylinder. Here we go. I need to turn my screen so I can see this clearly, and then we'll get to this question. So hold on. Alrighty, so it says an hourglass is in a cylinder. It's 2 inverted cones in a cylinder. The cones are filled with sand, making up half of the volume of the cylinder. What is the ratio of the cylinder to the cones? All right, Pedro, so here's the thing. I'm going to draw you a picture, and I want you to tell me if this is what you're looking for. So I'm going to focus on my students' questions first before I get into the fraction section. So here we go. Let me switch over to my screen so you guys can see my screen. All right, Pedro. I'm not going to be able to see your comments in the next couple of minutes, but I'm going to draw my conception of what you're trying to say here, which is 2 cones in a cylinder. And you're trying to find the ratio of the volume here. So I'm trying to get my sketch about. Here we go. This is from the Markov chain stuff earlier. But Pedro, let me know if this is your question. So you have a cylinder. Let me draw a better cylinder. draw a better cylinder than that. There we go. That's my attempt of a cylinder. And then you have two cones that meet somewhere in the middle. They're two inverted cones. So correct me if I'm wrong, but this is kind of what you're talking about. So I have two cones, and this is pretty much the region that these cones take up. Is this the correct picture, Pedro? I'm going to go back to my live chat to see what you have to say about it. I don't think I have anything. Oh, the cones are filled with sand, making... Okay, so then it says... so I got a yes. The cones are filled with sand, making up to half of the volume of the cylinder. What is the ratio of the cylinder to the cones? So are you referring to what's the ratio between the volume of the entire cones to the cylinder, or are you referring to the sand? Because the sand you're saying makes up half of the volume. I'm assuming you're saying what's the ratio between the volume of these two cones and the volume of the cylinder. Is that correct? Right. Yeah, so my question then is, so you're saying, yes, I know the cone, it's a third of a cylinder. My question to you, Pedro, is... are we trying to find the ratio of the volumes of the volume of the cones and the volume of the cylinders? Because in this case, it's actually not completely 1/3. It's actually a little bit less. The ratio is a little bit less. But are you trying to find that ratio? All right, so it's actually not 1/3, but you're on the right track. Yeah. So if you here, let me switch over to the. Oh, by the way, you can kind of see all of your comments, like, and when I read them, there's a little bit of delay, you'll notice. So I apologize about that delay. I'm gonna go over here and I'm gonna show you how to approach this. So you have these two cones. Oops, didn't want that. Let's try that again. You have these two cones, and you're trying to find the ratio between the volume of, looks like, this cone. Oh my goodness, it's not letting me. Let's try this one more time. We got this. I think I might be peaking my volume levels, so I'm going to turn my volume down a little tiny bit. There we go, and then let's try to open this. Oh. 1/3 divided by 2 is one cone. I actually don't know if that's true. I need to check that. So that was my thought initially, is that, why is this not letting me open up? I'm just going to avoid this. All right, so my initial thought was that, yes, this is half of a third, but let me test to see if that's actually true. I'm pretty sure it is. So in this case, it would be, I guess, maybe a 6. But here's what I'm going to do. I'm actually going to split up this cylinder into 2 cylinders. So here's the first cylinder. It's going to be half the height. And here's the other cylinder. Why is this trying to go back every time I want to undo something? I need to fix that. I'll fix that. I'm going to avoid. I keep using my left hand to try to undo this. And now it's not going to load. What do you know? All right, yeah, so I'm going to split that cylinder into 2 portions. And then I'm going to find the total volume of the red cones, and then the total volume of the blue cylinder. And then I'm going to find the ratio between those 2 volumes. So let's see if I can maybe make a new. This is not working. There we go. Now it's working. All right, so here's the top cone. And so I have here's the top cylinder. I have a cone in here. This is the top cone, top inverted cone. Now, the volume of this cylinder is pi r squared. And then technically it's times h over 2 because this height right here is half of the height of the cylinder. So this is the volume right here. And by the way, the reason why that is the volume formula is because we're taking the area of my base and I'm multiplying it by the height. And the area of the base is the area of a circle, which is pi r squared, and then times h over 2, which is half of the height. So that right there is the volume of the top cylinder, which is basically the volume of the cylinder divided by 2. Now, what about the volume of the cone? Well, in this case, the volume of the cone is pi r squared. Well, so it's pi r squared h over 2 times 1/3. And let me explain why. So in this scenario, we have a height that is this length right here, which is h over 2. And so it's pi r squared times the height. That is the volume of a cylinder. But when we're talking about cones, we have to multiply by 1/3. Now, over here, this guy has the same exact volume, which is pi r squared times h over 2 times 1/3. So the total volume is, and I'll use a different color here, that volume plus that volume. So that is pi r squared times h over 2 times 1/3 time, and then there's two copies of them, this one and this one. So I'm going to multiply it by 2 because I have 2 of them. Now that multiplication of 2 is going to cancel with that division. So this is 1/3 pi r squared h. Now that is actually the volume of this cone right here. It's kind of hard to see it, but if you inscribe a cone where that is the center, it's the same volume, surprisingly. But anyways, the volume of, so that's the volume of the cones. The volume of the cylinder is just pi r squared h. And so what's the ratio between them? You're absolutely right. It is 1/3. So the ratio between the volume of those red cones and the volume of the cylinder is 1/3. So let me see what you have to say about that, and maybe I can explain a little bit more in detail if you have any questions. That was a little fast, I know. But Pedro, if you have any questions, follow-up questions with that, I can definitely answer those. I'll give you guys some time to, maybe ask any follow-up questions. While you're doing that, I'm going to address real quick the new viewers. Looks like we have 8 viewers. If you guys have any math questions, feel free to post those math questions in the live chat over here on the right side. So I address any questions. Now, if we don't have any questions, I just address some random math topics. I personally today I chose fractions. I'm going to teach fractions today in a really different way. So that's kind of the default theme if no one has any questions. But again, you can ask any questions about volume, about the ratio of volume, maybe about, looks like I helped out Pedro. Thank you for your question. I really appreciate it. It's people like Pedro who make this channel possible. So make sure, if you haven't done so already, subscribe to this YouTube channel, ask your free questions, and I'll give you some free answers. So to the 8 viewers, you can ask any question about infinity. Maybe you're interested in some crazy topology or some manifold theory. I don't know. You could ask whatever set theory question you have. Maybe you're having difficulty in your calculus class. Maybe you're having difficulty in your differential equations, linear algebra class. Doesn't matter. I can help you guys through any of these math questions that you might have. So I appreciate your question, Pedro, and feel free to ask any other questions if you have any. And that goes to all the viewers that right now that are listening to. But again, subscribe to this YouTube channel every Thursday and Sunday at this time. we do free questions so you guys can ask whatever questions you guys have. All right, so let's move on to, it looks like we don't have no further questions. So I'm going to move on to the next portion of this course, or this lecture, which is the fraction section. So I'm going to move my mic a little bit over, a little bit in my face. There we go. So yeah, that is my mic. That's so anyways, let's go into fractions. So I ask my students very frequently, what is their conception of a fraction? Now, my take on this is pretty interesting. I'm going to give you guys real quick kind of a visual of my view on fractions and how I notice many students have. Like I'm gonna share with you my conception and the conception that I frequently see from my students. So let me pull up my notation screen here so I can make some writings. Computer's going a little slow today. That's okay. Alrighty, so my question to you, and this is just something I just want you to think about conceptually. How would you define this? 2/3 candy bars. My question to you is, how would you define 2/3 candy bars? Now, here are a couple rules. Number one, you're not allowed to use pictures. So I know a lot of students will want to just draw something like this. Let me see if I can undo that. Nope, I can only minimize the screen. So I gotta readjust the settings on this thing. I have to reopen that. There we go. All right, so yeah, when I ask this question to my students, very often I get something like this. They'll draw a candy bar, much better than my own, like a rectangle. This represents like the candy bar. They'll split it and do something like this, and then they shade 2 of these boxes, which is totally good. It's great, great visual representation. But if you were to describe this using only words, how would you describe 2/3 candy bars? Now, I'm actually going to make this a lecture in the future, in my future lectures, when we get into the Introduction to Mathematics course, which will come out after this statistics course that's coming out very soon. So let me explain to you how I often see students respond to this if they were to only use words. So what they'll say is 2/3 candy bars means you split a candy bar into 3 pieces and you take 2. So they say split. So there's 2 aspects. Split into 3 pieces. And take 2. Now there's actually nothing wrong with this definition, except it's going to make future math concepts relatively difficult. Now there is something that's a little bit tricky about, a little bit incorrect about this definition, and that's this first aspect right here. Because if I am, let's say, a 2nd grader, and I want 2/3 candy bars, then you tell me I split the candy bar into 3 pieces and take 2. Well, this is probably what I'm gonna do. I'm gonna take my candy bar. I'm gonna erase this real quick. Actually, I'll just erase everything. So this is 2/3 candy bars. So I'm gonna take a candy bar like this, and I'm gonna split it into 3 pieces. So that piece and that piece, and then I'll take this purple section right here, this piece and this piece, and then you can have this other piece. Now that's obviously not what we mean by 2/3 candy bars, because there's a very important word that we need to have, and that is, let me go back here. That's the word equal. So 3 equal pieces. That word is actually very crucial to the definition of fractions. Now, so far, most of my students are like, oh, okay, well, yeah, I kind of meant that. I just didn't include that. I just kind of assumed you understood that it was equal, which is totally fair. There's actually sort of a problem with this word, though, right here, take. And let me explain why. I'm going to ask you a very similar question. How would you define 7/3 candy bars? If you were to define that to like a little kid, and I would ask you, you know, what is 7/3 of a candy bar? What would you say? Now, in this case, if we use that same definition that we use for 2/3, this would mean that we split into 3 pieces and we take 7. Well, there's sort of there's a problem with that, right? How do you take 7 pieces? Well, when I initially was taught this, I was taught, well, no, you can take 7 pieces because there are 3 candy bars now. 1, 2, 3. And you split all of these into 3 equally sized pieces. And now you can take 7. But this really bothered me for a long time. Where did this second and third candy bar come from? Like, for the longest time, I only needed 1 candy bar. I never needed 3 candy bars to explain a fraction. And so it really begged the question, where did these other candy bars come from? And are they just appearing because? Because I was told that you take the candy bar, split it into 3 pieces, and then take 2 pieces. Or in this case, it would be take 7 pieces. But there's sort of a problem with that because I can't take that. And so I have to invent more candy bars so that I can. But that's sort of a problem, right? Because am I allowed to just willy-nilly create candy bars out of nowhere? And the answer is no. I can't just make up candy bars. So to me, there's a huge problem with how this is frequently taught. And I think the problem comes from the definition of 2/3 candy bars. And so I'm going to go back to the definition of 2/3 candy bars, and then we're going to come back to 7/3 candy bars in a moment here. So let me erase everything and explain to you what 2/3 candy bars is. Now, there's 2 aspects. The first aspect is the same. Split. Come on. And oh, there we go. Now I can write. And now there's a ruler here. There we go. So split into 2 pieces. Sorry, 3 pieces. And that is a 3, I promise. And then we're going to, instead of take 2 pieces, we're gonna make 2 copies of 1 piece. And this is why I think that this definition is so much more productive. Because when we talk about 7/3 candy bars, we don't have to adjust this definition. So I split into 3 candy bars and I make 7 copies of 1 piece. That is the definition of 7/3 candy bars. If I want to make, 4/3 candy bars, I just split into 3 equal. I forgot a very key word here. Equal pieces. And then I make 4 copies of 1 piece. So it's really important to understand that I think this definition is a little bit more productive. Now, if you've taken some math class that involved fractions, you've probably heard of 2 types of fractions: proper and improper. And proper fractions are like things like 2/7, and improper fractions are something like 9/7. So where this number is less than this number, and improper is when this number is bigger than that number. So to me, this is a really bad labeling of these things because there's nothing improper about these fractions. What's improper is our definition of proper fractions. And so if we change our definition of proper fractions, then these things are no longer improper. They're just as proper fractions. So these can be proper too, in my opinion, because if we have a really good definition of what a fraction is, then there's no such thing as improper fractions. So that's my bonus lecture to you guys. I'll get more into this type of lecture. These are the kind of lectures that are going to be in my Introduction to Mathematics class. And we're going to cover so many different things and hopefully conceptualize a lot of the building blocks of mathematics. So I'm really excited to teach that course. I'm going to go back to my live chat. If you guys have any questions, make sure you post your questions in the live chat, and I will address every single one of those today. So let's see if we have any questions. If we don't, then we'll move on for today. It looks like we don't, which is totally fine. I'm going to give you guys an opportunity to ask questions. So I'm going to give you guys like 2 minutes to ask any questions you want. Let me move real quick to a different screen here. There we go. So now you can see me a little bit better. So yeah, I'm going to leave you guys a couple minutes to write any of your math questions over here on this live chat, and then I will address those if we have any math questions. But as of right now, we don't have any math questions. We've addressed the brief lecture on fractions, and so for that reason, I'm probably going to end the session today. But again, if you have any math questions, I will address them. Just make sure you post them in the live chat. And as always, make sure you subscribe to this YouTube channel if we don't have any questions. Well, just to subscribe to our YouTube channel anyways. And so you can get, and make sure you click on that little bell. I believe it's going to pop up in a second here. Right there, that little bell right there, you see that bell? Click on that bell, because then you get notifications of when my live events are. So you'll be able to see that we're going live. But again, we go live every Thursday and Sunday at 9 p.m. Eastern Time, which is 27 minutes ago. And it's 6 o'clock Arizona time, but and I think right now it's 6 o'clock California time as well. So and 9 o'clock New York time. So make sure you check out our videos. Come by and ask any math questions you have, and we're going to be uploading some awesome content to this YouTube channel within the next couple weeks. So stay tuned to that. I'm going to go through this 2-minute intermediate period where you guys can ask questions if you have any. And in case we don't, thank you guys so much for all of your support, for coming here and asking your questions. Thank you, Pedro, for your great question on that volume, the ratio between the volume of the cylinders and the cones. And I will see you guys on Thursday, 9 p.m. See ya.